yeast rises into a conversation, it may not be the most exciting topic discussed over the course of your day. However true this may be, yeast can actually have a profound effect on concepts other than bread. My name is Destini Best, and I'm a rising 10th grader at Maggie L. Walker Governor School. This year was my fourth and last year participating in the MSI program, and it has been the most interesting one by far. This summer, I worked in Dr. Hilliker's lab focusing on yeast cells and their microscopic blueprint, also known as DNA. Throughout our project, my lab partner, Jamil, and I developed new skills as well as familiarized ourselves with some concepts that we have previously learned in the chemistry lab with the brilliant Dr. Case. This was all possible with the help of our mentor, Kenton. Kenton has a fun, creative personality with a teaching style that reflects that disposition. His rather vivid explanations of our objectives allowed me to retain a significant amount of information. He also encouraged us to stray far away from basic tendencies. In all seriousness, Kenton's bright character influenced my learning experience for the better. According to the central dogma of genetics, DNA replication copies the genetic code, transcription creates the RNA strand, and translation makes the proteins. We're looking at the process of translation to find a suppressor for a translation regulation factor named DED1. You see, this process can all be simplified in two similes that say DED1 is like a lock and the suppressor is like a key. When DED1 becomes overexpressed, it may stall translation by forming stress granules, which are molecular storage boxes. It also stalls this process of making proteins by blocking the ribosome from binding to the RNA strand. Ribosomes are molecular tools that are central to the production of protein. So the suppressor signals when DED1 has helped enough and removes it from the RNA strand. The DED1 protein also shows similarities to a protein in humans named DDX3. If the suppressor is found in the DED1 protein, it can be compared to DDX3 to see how diseases such as hepatitis C and HIV use this protein to replicate sick cells and what can eventually suppress them. In order for us to complete our final project, we first had to master different processes and techniques involved in the end result. A yeast transformation is the process in which DNA is inserted into the yeast cells, whereas a mini-prep is an extraction of DNA from the yeast. We focused on the sterile, streaking, and frogging techniques the most. The sterile technique prevents cross-contamination of yeast and bacterial cultures. The streaking technique allowed us to study a single strand of yeast, and frogging enabled a more efficient way to view multiple yeast cultures on a single plate. When I chose to attend the MSI program in 6th grade, I never imagined it to be as impactful towards my educational goals. I now have more options for my career choices, especially in the fields of science, technology, engineering, and math. Who knows? Maybe I'll go on to become a news anchor. Or maybe not. Whatever I choose to become for my career will always have a strong foundation of accumulated knowledge that I have received in my 4 years here at MSI. So now, if you ever find yourself in a conversation about baking bread, you know that there is more to yeast than what meets the eye, and that is what will make it interesting.